Alright, so this is a video I've been actually planning to make for a while, and I feel compelled to do this because I've been trying to explain to some friends of mine how OpenGL works, and when you're working with the code, it's really hard to get locked into the low level of it. So my goal here is to try and be as high level as is humanly possible. I'm not going to be using any code. I'm not going to go over the pipeline. I'm just going to go over the parts that are relevant to the programmer, high level as is humanly possible. This may work, this may not, but this is what I'm going to try. So I'm going to start here. I'm going to say we have a goal, a graphical goal. So I'm going to put right here. This is going to be the screen that we want, and all we're trying to do is, let's say, draw our... Actually, there's a better way to do this, I think. Yeah, there it is. So we're just wanting to draw a simple triangle to the screen. So we're going to call this our goal, or our desired result. All right. And the parts that we're going to talk about are going to be, and I'm going to make these, because these are real world, I'm going to make these, oops, having a little bit of trouble with my mouse. I'm going to make this a little bit bigger so that we can kind of get a sense of what's going on. So this is going to be the CPU. So this is the program that's running on our tower. Not saying the graphics card's not in the tower, but then right here we're going to have the GPU. So this is the graphics card, and over here I'm going to put, we're going to say, like, this is the result, just for fun. Alright, so of course everything starts with our program, and our program is driven by our requirements, and our requirements is to draw a circle. So, or pardon me, a triangle. So our little bit, we're going to say our program right now is executing on the CPU, and I'm going to do a different color here. So I'm going to do some pseudocode. So the first thing we need to do is we know what we're trying to draw, and so we know we represent our triangle as 2D coordinates. So I'm going to go ahead and skip ahead just a little bit, and we're going to say that our coordinate system is the upper left-hand corner is, I believe it's -1, comma, -1, and our lower corner, and this is definitely not to scale, so I recognize that. Alright, so we are going to represent this triangle as coordinates that fall in between these 2 points. So 0, 0 is going to be dead center of the screen. So let's say that this is 0.25, comma 0, and let's say this is minus 0.25, comma 0, and we're going to say that this is minus 0.25, comma 0.15. So it looks relatively correct. So we're going to have an array in here. So it's going to be our points, and I'm just going to do that for array. So it's going to be minus. So let's go ahead and do this counterclockwise. So I'm going to start with this being 0.1. So it's going to be 0.25, comma 0, comma minus 0.25, comma 0, comma minus 0.25, comma 0.15. Alright, so now we've got our array in our code. So the first thing we're going to do is we're going to send some commands over to the GPU, and we're going to say create what's called a see, it's called a VBO, pardon me, I believe it's called a VAO. So it's a vertex array object. And this is a command we actually feed over to the GPU. All right. So when we send that command over to the GPU, of course, has, and we're going to do it, trying to think how much. Okay, so we're going to say that this is the RAM inside the GPU. So my nephew was just telling me there's a great new graphics card that's got 32 gigs of onboard RAM. So 32 gigs of RAM. So what's going to happen is when we get our, we're going to request that the graphics card create a vertex array object. So it's going to allocate us a block. I'm just going to describe it as a block of memory, although it probably doesn't work that way. And it's going to say we're going to call this 1. All OpenGL names, they call them names, but they're numbers, but they're pretty much just labels. So this is vertex array object 1. Oops, let me put the V on there. All right, so now whenever we bind the graphics card to vertex array object 1, it'll point there. So we can make as many of these as the graphics card can handle. And that's an unsigned integer, so that'd be probably quite a few. All right, so then we tell the graphics card, all right, so inside of this vertex array object, we want to create, oops, I apologize. We want to create a vertex array buffer. And now this is going to be a little bit of a different animal. So we tell it we want to create the vertex array buffer object, and once again the graphics card will create us a buffer, but right now we're bound to the vertex array object 1. Now I'm going to say this, I probably should have said it earlier. Graphics cards are very stateful. So you actually have commands that put the graphics cards into specific states. So you can only have one vertex array object active at any one time, and you index them through their names. So because we had the one we just generated active, when we bind the vertex array buffer, it's going to be associated with this vertex array object. So, and usually in my experience, that first one is given the name 1. So this would be the vertex array buffer. All right. So, and then after that, we tell it, we describe our buffer. So in this case, we're going to put the data to the buffer, and we're going to say, hey, this buffer is made up of 1, 2, 3, 4, 5, 6 floats. I'm a little ashamed I had to say it that way, but I did. So anyway, so these are floating point values, and there are 6 of them. Alright, and so what's going to happen here is we're going to actually load that data into this buffer. So it's going to be an array. So I'm going to go ahead and just retype this for the sake of let's see, 0.25 minus 0.25. Comma 0.15. All right, so 1, 2, 3, 4, 5, 6. Okay, so now we've got our array, and it's been associated with this vertex buffer. So we're good. As far as, okay, so all this data is now loaded into the graphics card. The next thing we would do, or we could do, is we establish the shaders. So the shader code is actually going to be loaded onto the graphics card and compiled. So actually, I'm going to go get us some actual shader code just to help with the illustration. Okay, so here are our two shaders. I went ahead and put them in code, and it also reminded me that I forgot to do something very important. Now, so we've got our buffer here, but we have to tell our vertex array buffer object, we have to bind how it is to be interpreted by the shader. So we're going to have to create what's called a location. So we're going to say location 0 is equal to 2 GL floats, and we're going to have to tell it a couple of different things, but for right now I'm just going to keep this really simple. So we actually have to tell it that these are read in groups of 2. We have to say where the buffer starts and what the stride is. Just mentioning those names, but I'm not going to go too deep into it. So this will become a little more apparent what's going on. And actually, I'm going to go ahead and copy, because I believe that lives on the graphics card. It's actually associated with, oops. Sorry, I'm having a little bit of mouse trouble here. So I'm going to put this right here because this is associated with the vertex array buffer. Alright, so now we've got our buffer all set up. So next we need to set up our program. So we're going to say, pretty much it's the same thing. Again, the graphics card is stateful. So we say create vertex shader, and what's going to happen is it's going to set aside a block of memory, and that's going to be where we bind our vertex shader. So it's going to be, usually it's just one, and then we're going to, this is, I thought, really interesting. What we do is we actually pass the text data into it, into the memory provided by the graphics card. So we pass Alright, so after we've done that, now our shader code lives here. I'm not going to go ahead and copy the whole thing over, but I will draw a little arrow. So let's see, this is the vertex. Yes, this is the vertex. Alright, then we do something similar with we create, oops. Again, we get a name, and in my experience, these things tend to go in order. And you could do, again, as many shaders as the graphics card has memory to hold on to them. I've never been able to test that, so that's a guess on my part. So then we got our fragment shader. Now the reason we pass the string code to the graphics card is that the different graphics cards might have different chipsets. So a program compiled, a shader compiled for a NVIDIA card would for sure not be compatible with a AMD card. But I mean, even more so, an older NVIDIA card wouldn't be able to run code that was compiled on a newer one. So what we do is we actually pass the code to the graphics card, and the graphics card has a built-in compiler that will compile these programs down into runnable code for the GPU's smaller processors. So pass the fragment shader, and I'll go into what the different shaders do here in just a second. So pass the fragment shader. All right. Oops. And I'm going to draw. Again, I'm going to draw a line, so you can imagine these strings have now been pushed over to the graphics card, and they now reside on there. So now we create a program. And this is where the program is actually a collection of our custom shaders that get, again, a name. So it's going to be program 3. I've noticed that it doles, oops, I just realized I screwed up. I realized that it doles these numbers out in order. So when you give it the first one, it gives it shader name 1. There we go. So the fragment shader would be 2. And then the program shader will be, or the program will be the collection of shaders, which would be 3. And then you call the link, the linker. And then program 3 now becomes the binding for these shaders. Alright, so this pretty much constitutes a setup graphics card for doing our drawing. Of course, I'm completely overlooking setting up the context and everything else, but I'm more interested in what happens once we actually get things going. So, alright, so now let's say we're in our main routine, our main loop. So we've already initialized our card. Now we have our buffers put in the card, and we've got this. So the first thing we have to do is bind the VAO. So if we don't already have it, we set the graphics card and say, actually here, let me, just for the sake of, so bind VAO1. So we say, hey graphics card, VAO1 is the one we want to work with. So the graphics card puts that to its active state. We bind the, let's see, ABO. Yeah, the array buffer object. I think that's what they call it anyway. So now we know we're looking at this guy. And we say use program 3. And so that will take program 3 and make it active. And I'm running out of room here, so I'm just going to type the next thing here. So you say draw array, and you tell it how you want it to be drawn. So we would say triangles, and we would say we got 3 points. There's a little more to it than that, but pseudocode. So as soon as this happens, what's going to happen is it's got this program bound to this buffer. So the location specifies how it's to be read. So we read this in 2 GL floats. So it's going to create an instance of the fragment, the vertex shader for every vertex we have. So we've got 3 vertexes. So it is actually going to load up a separate copy of this program 3 times. Let's see. And I'm going to copy this just so we can see it working. So we're going to oops. And because of the layout location, the first one is going to get these 2 points. Actually, I'm going to color code these things. So we're going to say R, and that gets these 2 first points because 2 floats. Green. This one gets crumbs. Alright, my apologies. Alright. And then green, because it gets these 2 points. And then blue gets these 2 points. And what's going to happen is, so this vector of 2, POS, is going to be equal to and my paint skills are not what they need to be. Anyway, so POS is going to be 0.25 comma 0 for this one. POS is going to be minus 0.250 for this one, and POS is going to be minus 0.2515 for this one. And this is the power of the graphics card. It actually loads these programs up simultaneously in the multiple cores of the GPU. The CPU, you'll hear, it's like a single specialized processor. A GPU has, I want to say the last one I heard of, NVIDIA card has like 1,000 CUDA cores. So it can run 1,000 of these little simple programs simultaneously, and it will do its thing. So in this case, these points will be passed directly to GL position. And so for this vertex, that'll be the output, just the coordinates. This is a really simple shader. Same thing for this one, same thing for this one. So it will draw our points. It'll draw our points right here because it just passed them straight on through. Everything was already drawn. No math needs to happen. So then the fragment shader comes in. Now, I'm not going to go into a whole lot of detail, but the fragment shader actually fills this guy in. So we already told it we're going to draw a triangle, so it knows that it needs to connect these points. And I chose to draw this as a right triangle for a very specific reason. The way the math works is this slope is a known quantity, so as you iterate down or up, you know you can easily calculate where this is. So each point that makes up the inside of this triangle represents a single fragment, not a pixel, because if you think about it, the pixels on the screen are the small dots, and if you have like let's say a really low resolution triangle, a single fragment might be multiple pixels. So very important, a pixel is not a fragment. But alright, so it's going to run a simultaneous copy of our fragment code again for every point inside this triangle, and it's going to output a single color, and it's RGB, and I'm not going to go into A, but so I was going to say RGB, and actually I'm going to do that black so there's no confusion. So R, G, B, and A, although A has to be turned off. So it's going to paint each and every single point in there red. So it's actually going to, oh come on, thing, won't let me fill it in. It's going to simultaneously fill that all in red. And I don't know why it won't let me fill. Oh, there it is. So that's it. And then it'll be done. It will have drawn our triangle, and it will have filled it in red. So I tried to keep this example as simple as I could, and I overlooked setting up the graphics context, because that's stuff you can look up. This is, I think, what makes it so powerful. So this is a very basic setup for OpenGL. You load in your data, you set your program, and then you draw it. If you wanted to make this move, you could actually pass values into the shader. They're called uniform variables, and add offsets to the positions. But again, I don't want to go too much into it. So I hope this clears it up for some of the people I've been talking to. If anybody has any suggestions or any questions, I'll be happy to answer them. I hope this cleans some things up. I hope everybody has a good one.